In the last part of Unit 5.6, we are going to put all the things together that we've learned and sketch graphs and find properties of quadratics. So, just a refresher on the properties of a quadratic function. What are the things we can find? Well, we can find the x-intercepts. And in order to do that, we looked at factoring. So we can find the x-intercepts by factoring. We could also find the x-intercepts using the quadratic formula. We know how to find the vertex. We've done that. In order to find the vertex, we completed the square to change standard form to vertex form. So that's another thing that we know how to do. Once we know the vertex, we know the axis of symmetry, because that goes through the vertex. So if we know the vertex, we know the axis of symmetry. And we also know how to find the y-intercept. We just put x as 0 and we determine what y is. So we know how to find all these things on a quadratic. So we're going to look at a couple of equations and find all these properties. So in the first quadratic, we are given a quadratic in standard form. Remember, standard form is ax squared plus bx plus c. So because it has a negative, it starts with a negative coefficient, we know that it's going to be concave down. We can find the y-intercept by letting x equals 0. So all I'm going to do is replace x with a 0. And that gives me a value of 8. So I know the y-intercept is 0, negative 8. So I can start by putting that point on my graph here. I can find the x-intercepts either by factoring or the quadratic formula. That's entirely up to you. I'm going to factor. So because I am factoring and solving, I'm going to set it equal to 0. You can't start brackets with a negative. So the first thing I'm going to do is factor out this negative coefficient. It's actually a negative 1. So I'm going to divide all terms by negative 1 before I factor. Now I have a simple trinomial. So I want two numbers that multiply to get negative 8 and add to get negative 2, which would be negative 4 plus 2. And then finally, I am going to set each factor equal to 0 and solve for x to find those x-intercepts. So I have two x-intercepts, one at 4 and one at negative 2. So there's another 2 points I can plot. Now I want to do the vertex. So it is in standard form. So I'm going to change it to vertex form. So again, I can't start with a negative, so I'm going to take this negative out of the first two terms. I'm going to complete the square. So I'm going to take half of 2, which is 1, and then I'm going to square it. So plus 1 will complete the square, minus 1, so we don't change the equation, and then I still have this plus 8. So don't forget, if you factor out a number, you have to multiply it back. So I've got negative x squared minus 2x plus 1 factors to x minus 1 times x minus 1. I've multiplied the negative by the negative 1 to get positive 1, and then I have 8. So in vertex form, it will look like that. So now I know the vertex. The vertex is 1 and 9. So I'm going to plot that on my graph here. And then I can connect these points together to make my parabola. So I have determined that it's concave down. I put in 0 to get the y-intercept. I factored to get the x-intercepts. I completed the square to get the vertex. The axis of symmetry goes through the vertex, so it's right here. This is my axis of symmetry at 1. And I've got my sketch. And now once I have my sketch, I can state the domain and range. I know that the domain is any value for x. We are not limited to x. We can use any number we want. And then y is any number, but y is limited by whether it opens up or down. So since this opens down, it has a top, right? There's the vertex. So the highest point is 9. So we want all those y values that are below 9 or less than 9. So once you have your sketch, you can do the domain and range. We always do that last. Okay, so let's try another one. We have the same question. We just have a different equation. So this time it's a positive x squared. So I know it's concave up. The y-intercept, I'm going to put in 0 to find the value of y. So that's going to be negative 15. So the y-intercept is 0, negative 15. I'm going to factor it to find the x-intercepts. It's a simple trinomial. 5 times 3 is 15. It has to add to positive 2, so it must be plus 5 minus 3. And so my two x-intercepts are negative 5 and positive 3. So I'm going to start to plot these points on my grid here. Do I have a grid? I guess I don't have a grid, so let's draw one. Okay, so I've got negative 1, 2, 3, 4, 5. 1, 2, 3. There's my x-intercepts. My y-intercept is down here somewhere. I don't have to be too accurate. I'll just put it there, 0, negative 50. I'm going to do my vertex, so I need to complete the square. So I'll take half of 2, which is 1, and square it. So plus 1 will make that perfect square, minus 1. And so in vertex form, we have x plus 1 squared minus 16. So the vertex is negative 1, negative 16, which is just below this point here. So my graph is going to come up here. Come up here. This is my vertex at 0, negative 16. Sorry, negative 1. And my axis of symmetry goes through the vertex at negative 1. So that's my axis of symmetry. And then finally the domain and range. Again, a parabola will always have a domain of any real number. And this time it has a bottom, right? It has a low point. So we'll say y has to be above the lowest point, which is negative 16. Okay, this question is given in vertex form. So it's a little bit different information, but we can find all this information, whether it's in standard form or vertex form. It is a positive x squared, so we know it's going to open up. It's already in vertex form, so I can tell the vertex. I don't have to complete the square, so I know it's at negative 2, negative 5. Do I have a grid on this one? No. I guess the grid didn't come up. All right, so I'm going to start to graph this. So we'll draw an x and y axis here. So my vertex is at negative 2, negative 5. I know it's going to open up. My axis of symmetry is going to go through that vertex. So my axis of symmetry, let's label this vertex as negative 2, negative 5. So my axis of symmetry is going to go through at negative 2. I can find the y-intercept by plugging in 0. Let's do this over here. So I'm going to find the y-intercept by subbing in 0 for x. So it's going to be 0 plus 2 squared minus 5. So 0 plus 2 is 2. Squared is 4. And then minus 5 is negative 1. So the y-intercept is 0, negative 1. So I'm going to put that on here. So 0, negative 1. So since it is symmetrical, I know that there's going to be a point on the other side that's the same distance. So this y-intercept is 2 units from the middle, so there should be a point on the other side that's also 2 units from the middle. And so that gives me the third symmetric point. So that's what it's talking about, a symmetric point to the y-intercept. There should be a matching point on the other side. So the matching point on the other side is at -4, -1. So I don't really need to find the x-intercepts. I just need to find a symmetrical point. So when you factor and find the x-intercepts, you have 2 points that are on either side. If we have the y-intercept, we can find a point on the other side. So I've got my sketch. So I know it's concave up. I found the vertex. I found the axis of symmetry, the y-intercept, and a point symmetrical to that. I sketched it. And then my domain and range is any real number for x. And the range, we have a bottom, so y is going to be above this lowest point, which says at -5. All right, let's do one more. So this time we have a -2, which means it's going to turn down. Again, it's in vertex form. So the vertex is going to be 1, 4. The axis is symmetry, so let's start to sketch this. So we have a vertex at 1, 4. I know it's going to turn down. My axis of symmetry is going to go through that vertex. So it's going to be at 1. I'm going to find the y-intercept by letting x equal 0. So I get -1 squared, which is +1, times -2 plus 4 is +2. So my y-intercept is 0, 2. So put that on here. And then I'm going to have a point symmetrical to it on the other side of the x-axis, so it would be here. So it's 1 unit to the x-axis, it'll be 1 on the other side, and then I can sketch my graph. And then finally, the domain is any real number. And the range, this time we have a high point, so the range is going to be below this point, which has a high point of 4. So it's anything below 4.